Good afternoon, Manoj.
Yeah, mom. Had your lunch?
Yes, I've had my lunch. So, can you give me the brief introduction of yourself?
Okay, mom. Thank you for giving me this opportunity to introduce myself.
Yes,
My name is
yes,
Manoj
yes.
Kumar. My name is
Okay.
Manoj Kumar, and I completed my bachelor's degree in KL University, Vijayawada. I'm specialized in VLSI, ECE VLSI. So my university provides, along with the electronics and communication, we need to do one specialization, and I opted for VLSI as my specialization. There, the enthusiasm raised me to taking the course advanced advanced design and verification course in Maven Silicon. I completed in June itself, and there I learned a lot about digital electronics, Verilog, system Verilog, and UVM. The hands-on training has been provided by the institute, and after that they conduct one final test. I given that final test, and I topped in that final test. Actually, I am very much interested in the electronical components from engineering itself. There I did a lot of projects based on ESP32 microcontrollers and Raspberry Pi and other embedded systems. And thereby I got no, then completely it was dependent on the chip, which is VLSI. So I'm choosing the front end as my part. And coming to hobbies, I am very much like to watch the movies, and I wanted to acquiring the knowledge is my best therapy for the relaxation. And my goal is to get placed in a good company, and my long-term goal is to become a finite design verification engineer in this field. That's all about me now.
Okay, nice. So, which subjects you are in, like specialize?
uh, like semiconductor memories and algorithm for VLSI, low power VLSI, VLSI design, and uh, IC fabrication. In these parts, these are
But
like electives.
why you chose the design verification field?
Yeah, mom. Actually, I'm very much into the coding. In the electronics time, people used to be very sophisticated about the software. So I learned some part about the coding language like C. And if I choose the field which is related through my learning, that will be benefited for me. So that's why I chosen design verification as my field. Since electronic components are from the electronics, so we need to know about the electronic components as well as coding in the front end part. That's why I chosen the design verification partner.
Yeah, but you have not said any of the subjects from the design verification part. Like you said that fabrication and analog part.
Yeah, ma'am.
You have not mentioned that any digital Verilog something.
Yeah, actually, these subjects were included in my global certifications. In our university, we need to do 3 global certification in that particular
Okay, okay.
specialization. So I did design verification and UVM uh, by the test. It was provided by the test solve. So there I know about the system Verilog and UVM. And also
Okay.
through the Maven Silicon, also in my training institute, the hands-on experience I got about these languages.
Okay. So which projects have you done?
AHB to APB bridge, a RISC-V project, and router project, and APB based GPIO verification I did.
Okay, you have created the APB environment.
Yeah, ma'am. APB environment for communicating with the GPIO, general purpose input output modules, the peripherals.
Mm. Okay, so can you tell me about the APB protocol?
Yeah, ma'am. Here there was 3 setup. Like there were 3 parts. Setup, enable. Ma'am, actually, I have not referred the projects. I know I remember about the project, so that's I'm going to tell. Is it fine, ma'am?
What?
Actually, I didn't refer the projects. Just I prepared digital
You have
electronics,
not. Okay, okay,
Verilog system,
okay.
Verilog, and UV. That
Okay,
was
okay,
informed
fine.
in the 9:30 yesterday.
Okay, fine, fine. So, do you know about the complement in digital electronics?
Sorry, ma'am.
Complement, complement.
Yeah, ma'am. Like one's complement, two's complement, n's complement, and n minus one's complement.
Yes, yes.
Yeah, ma'am.
So, like, how many complements can be possible, right?
Like we can do lot of complements, like one's complement, two's complement, three's complement, four complement, like any number that was n in the place of n and n minus one, we can do any complement, ma'am.
But there is a term radix, if you know.
Yeah, ma'am.
What
Base
is the
2.
meaning of the radix?
Radix means the base representation, either the decimal representation, hexagonal representation, or what type of representation we are using. Through radix only we are going to know, ma'am.
Yes. So, okay. So for the octal, what complements can be possible?
8, n is equal to 8. So 8, 8 complement and 7's complement is possible.
Yes, yeah, R and R minus one. Okay, right.
Yeah.
So, what can be range for the one complement and two's complement?
Uh,
Range for the
the
one's
range
complement
will
and
be minus 2 to the power of n minus 1 to 2 to 2 to the power of n plus 1, ma'am. That is the range.
okay, for one's complement.
For one's complement,
Yes.
2 to the power of 1. So it is two values, ma'am.
Okay, and for unsigned numbers.
Uh, Unsigned numbers, it is 2 to the power of 2. It's 4. Like either 0 and 1 will become in the MSB bit. Now to represent either it is, if we are using 1, then it is a negative number. If it is 0, it is a positive number for the signed numbers. For unsigned numbers, it is 0 and 1. That's it.
Okay. Okay, so do you know about the Johnson counter? What is the use of the Johnson counter?
A Johnson counter is also known as a twisted ring counter, ma'am.
Okay.
And uh, basically these counters are used for the counting purpose, and the mod value is 2 to the power of n.
Okay, so the output, does the directly output is
Yeah,
transferred to the input?
yeah, ma'am. The feedback loop is there from the complement term.
Okay, from the complement one. Okay, right. So, what do you mean by the 4-bit binary counter?
uh, 4-bit binary counter is going to count the binary digits, which is ranging from 0 to 2 to the power of 4. Like we are using the 4 bits. So 4 bit 2 to the power of 4, 16. So 0 to 15 we are going to count by using the 4-bit counter, ma'am.
Okay, so can you like design the 4-bit counter using T flip-flop, 4-bit
For
binary counter
yeah, ma'am.
using the T flip-flop?
Sure, ma'am. Can I share the screen?
Yes, yes. You use which simulator, Vivado or like EDO?
Yeah, ma'am. I'm familiar with Xilinx Vivado and also
Okay,
Xilinx ISC. EDA Playground also, I'm familiar with that.
okay.
Ma'am, I hope my screen is visible. Ma'am, ma'am, hello.
Hello. Yes,
Yeah,
yes.
ma'am. Is my screen visible?
Yes, your screen is visible.
Ma'am, like if it was a D flip-flop,
I said T flip flop.
yeah, ma'am. That's what I am saying. Like if it is a D
Okay.
flip-flop, then we can connect all these things. It will going to count all of them. But since we are using the T flip-flop, uh, we need to count the values like which is ranging from 0 to 15. So first one is 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. Like till we need to go for double one, double one. This is 15 mark. So here the basic functionality of our T flip-flop is whenever we are providing the value as 1, then it is going to toggle the previous Q value. If our Q value is 0, then it's going to toggle to 1. If our T flip-flop input is 0, the previous value, the Q value will going to be same as it is.
Okay.
That is the working of our T flip-flop.
Okay. So do you know the difference between the latch and the flip flop?
I am a do. Um,
What is the difference between them?
okay, ma'am. Here the flip-flops are made from the latches, and the latch and flip-flop. The basic difference is latch is a level trigger. Throughout the level, either from 0th level or the 1th level, we are going to change the value, and the output is going to be changed here. But in the flip-flop, it is a edge trigger. Only the values is being changed in the edges only.
Okay.
Due to this alpha value, the factor will be high for latches. Like the number of transitions is high, so it is prone to a race condition or the metastabilities. The unknown values is going to be occur here, but in flip flops, it is can be avoided. The glitches will be avoided here.
Okay.
Basically,
So
the flip flop is the master slave configuration of our latch only.
okay. So there can be like two types of latches. What can be?
It is negative edge triggered negative level drag and the positive level drag, like zero low level tag and the high level latch you are asking
So
about.
you need no.
No,
Do you know
yeah,
about the flip flop types?
flip flop. Yes, ma'am. I know. Yeah, okay, ma'am. I understood your question. Sorry about that. SR latch, JK latch, and D latch, and that's what you are asking.
No, the I'm talking about the synchronous and asynchronous types.
Yeah, ma'am.
Okay. So can you like describe it? The synchronous and synchronous part?
Yeah, ma'am. In synchronous, the flip flop, the group of flip flops is involved, and it is the functionality is based on the the functionality with respect to the clock. It is synchronous. In asynchronous, the flip-flop operation will not depend on the clock. That is the asynchronous one. Like if you are using here, we are using the four
So it's
flip-flops.
not dependent on the clock for
Synchronous.
asynchronous.
In asynchronous, the clock will be dependent, ma'am. But the same clock will not be provided to all the flip-flops. Different clocks will be
Okay.
provided. In synchronous, the same clock is provided to all the flip-flops. But in asynchronous, we are going to provide different clocks. Maybe in the phase difference. If the phase difference are are from the same PLL, are from the different PLLs, we can provide the clock in asynchronous. It was clock one.
Okay. So PLL give the synchronous circuit or asynchronous?
Synchronous circuit only. No?
Yeah. The output is related to the input, you are saying, in
Yeah,
PLL. Okay. So for asynchronous, we need the two PLL.
for asynchronous, there we need not uh, not the two PLL, but the asynchronous domain will be with the two PLLs. But we can also use the same PLL in order to generate the asynchronous clock.
Okay. Okay, fine. So do you know the difference between the synchronous and asynchronous reset?
Yeah, ma'am. I know. If we are providing uh, uh, we are providing the result in the argument of our always at the rate of positive edge of clock comma positive edge of reset, then our reset will be synchronous. If we are if we are not providing, then it will be asynchronous.
Can you
Like
write the
in
very
synchronous.
Verilog code? Okay. Can you write the Verilog code and test bench for the T flip flop for both synchronous and asynchronous reset?
Okay, ma'am. Like like here while we are applying the reset application will happen through based on the clock, either in positive edge of the clock or the negative edge of the clock. That is synchronous one, ma'am. But if it is not dependent on the clock in if you are providing the reset value, then at that time instance itself the reset value is applying to our system, then it is asynchronous one.
Can you please write the code and then explain that?
Yeah, ma'am. This one is synchronous with reset, and this one is asynchronous reset.
Wait. Can you like repeat
Okay, ma'am.
by
Here,
showing that I'm not able to see your arrow. Like, okay.
okay, ma'am. Here, is it visible, ma'am?
Can you like maximize it?
What about now, ma'am?
Mm. Yes, now I can see it. Actually, your video is showing me in buffer time.
Okay, maybe the network glitch, ma'am.
Yes, yes, yes. I think. Okay.
Here, the module T flip flop synchronous reset. I'm providing the input and a port declaration is happening here, and after that, in the positive edge of clock, these are the events I am providing. Whenever the positive edge of clock will occur, and the positive edge of reset, since it was a synchronous to reset. So whenever the positive edge of reset is occur and the reset is high, then our output will be zero. That reset application is happening here, and if
Okay.
it
Okay,
is
fine.
asynchronous, and if it is asynchronous, then at instance of time, whenever the reset we are providing, at that instance itself, it's going to provide the zero value. And this is the coding
I
style
think
for
you have made
asynchronous.
the opposite one. For synchronous, it should be like dependent on only the clock, and for asynchronous, it should be independent of the clock.
Yeah, ma'am, yeah. For asynchronous, it is
Independent of
yeah,
the
yeah,
clock,
that's
right?
why here there is no need of providing that thing. This one is asynchronous.
Yes, yes. So, do you know about the mod 3 counter?
Mod 3 counter, yes, ma'am.
Okay, so before
Count will
that,
be
can you
0 to
like,
7.
yeah, before that, can you like write the test bench for this code, for the T flip-flop code?
Yeah, ma'am. Right.
I just need the framework, right? No need to like write the everything. You just,
Okay, what and all I'm like tasks is enough.
yeah, you should explain me the framework of the test
Okay,
bench.
ma'am. First, I am going to write the module, and then after that, I am declaring all the signals. The T clock reset, these signals will be as a reg type, and the output signals will be wire type. Then I am
Why,
instantiating
why?
the module, ma'am.
Why it should be like reg? Because in duty it was like wire type, right? So why we in the test bench we use the reg?
Yeah, the test bench, wait, now, wait a minute. Here, this is our DUT, and this is going to be our test bench. Here from test bench, we are providing the value to here, and we are sampling those values here. So our test bench
Manoj,
here, to what and all,
uh,
ma'am?
can you like rejoin the meet as I'm getting your answer in very delayed?
Okay, ma'am, wait a minute. I will rejoin.
Yes, thank you.
All this reset task. Then after that, I will call my T flip-flop driving values. And then after having some ash 100 or 1000 delay, I'm going to call the dollar finish. That is my test benchmark.
Okay, so do you know about the regions in the Verilog?
Yeah, ma'am. There were active region. First one is preponed region, active region, inactive region, non-blocking assignment region, and after that, postponed region. Basically, these regions has been designed in order to overcome the glitches, the race conditions.
Okay, so the dollar strobe is in which region?
Dollar stroke is going to execute at the last of the time strap, ma'am. Like in the
So it will
post
lie in
region,
which region?
postponed region, ma'am. Like the last time straps postponed region.
That's correct, correct. You can continue with the test bench.
Yeah, ma'am. That is how the test bench is going to drive the values, and we are checking through the waveform. That's it.
Yes, okay. You were writing the test bench for T flip-flop, right?
Yeah, ma'am. So can I write the test bench, ma'am?
Yes, yes, yes.
Oh, okay. Like I am using the order based one, ma'am. We can provide through name based and order based. So I am preferring the order one. That's it, ma'am.
Okay, fine. So, what is the mod 3 counter? What did it do?
Mod 3 counter is going to count from 0 to 2, ma'am. Like the three values 0, 1, 2. These three values is going to be counted.
Mm.
Like if you are using the 4-bit counter or the 3-bit counter, but it needs to count from 0 to 7 if it is 3-bit, or if you are using the 4-bit, it needs to count from 0 to 15. But due to the mod value here, we are restricting to the 3 only. So whenever if count equal to 3, then we are going to be assigning the 0 value, the initial value again. So it is going to count from 0, 1 and 2.
Okay, so it will like in sequence 0, 1, 2.
Yeah, ma'am.
Okay. Do you know about the inferring latches? Latch inferring concept.
Yeah,
What do you mean
ma'am.
by the inferring latches and how we can like avoid it? Do you know about that?
The latches is going to be inferred if we are using the case statement. The default statement we are not providing, or if we are using the if statement, we are not providing the else statement, then the latch is going to be inferred by the system. Like
Mm-mm.
here, uh,
Mm.
case statements. So we are providing the case values. Here there were two, like s s1 and s0. We are providing values for this one and I0 and I1 values, and we are not providing any values to the remaining values. So these remaining values is going to be feedback to the output. This is nothing but inferring the latch.
Okay.
So these can be avoided in the coding style. We need to provide the default statement for the case statement, and we must and should need to write the else case for the if.
Okay. So if we don't write the else case or we missed any case, it
The
can lead
inferring
to the
latches is going to be happen, ma'am.
okay.
And also like if we are having the values, like there were 32-bit value is there, but we are providing only 8 bits value. At that time also inferring the range is going to occur, ma'am.
Okay. So in the chat box, I am providing you the one code. You have to give the output of that code. Okay. Like you have to show me that what will be the output of this code.
This is the code. Okay, let me
Yes.
run. Always at the rate of here we are not providing any positive, so it was just a signal. It is a clock. So and whenever it becomes 1, then only this always block is going to execute, and a is equal to 0, then a we are driving with the non-blocking value 1 and displaying. Here the display value is going to be happen in the active region, which is before the non-blocking region. So value of a will be printed with 0.
Okay, correct. What will be the output of this?
Correct. P, Q, R. Sorry, ma'am.
What will be the output?
Here you are asking about the second snippet or the first snippet, ma'am.
First you have
First
told
it was
the
0.
correct. Yes, yeah. First was
Second,
correct. I'm asking about the second.
okay, ma'am. Here you are giving the PQR values a reg. By default, the PQR values will be unknown, like X in the initial begin end. So it's going to execute in a single time, and P value will be non-blocking with 1, and after that Q value will non-blocking with 0. This process will be going to execute in the concurrent way. So R will be P and Q. So q value is 0, p value is equal to 1. Here display, we are displaying pqr. Like the same thing, ma'am. Like the default values is going to print. Like p is equal to x, q is equal to x, r is equal to x. Neither of these values
Okay.
is going to be printed, ma'am. Only the default values will be printed.
Okay, fine. Can you like generate the clock in different ways?
Yeah, ma'am. Like, why it is, hmm. So, this is one way, ma'am. And the another way will be uh, always.
Okay.
Hmm. At the rate of 1 is also going to low.
Yes.
Yeah, and these are the three different ways of generating the clock. Using the forever and using always and using always, and I am providing the constant value. So going to repeatedly it will execute now.
But it will never end. Like we
It will
don't.
go into the deadlock condition.
Yeah, okay. So if I write the forever inside the always block, what will happen? Like
Forever inside always block.
yes,
Like always with the event or without event, ma'am.
whichever you are comfortable with. But I want to know that what will happen.
Uh,
There will be error or something or not.
uh, on Yeah, ma'am. Forever it's going to execute. Like you are saying. Like this is what you are asking, ma'am. Whether it
Mm.
puts the error or not.
But the A will never trigger a right, I think.
Uh, yeah, ma'am. Through if you are providing,
The test bench.
they are assuming like the A will be one. Whenever the
Okay,
A,
okay, okay.
then the forever B is equal to one is going to happen. Like every time the A
Yeah,
value,
what will be the meaning of this? Like we have written the forever inside the always block.
uh, always that value will be one only, ma'am. There is no change in that value.
What is the difference between the always and forever?
Like always has events, ma'am. Forever has no events. Like it has the controlling field. Forever don't have controlling field, and always is a procedural block, and forever is a looping statement.
Yes. So we cannot write it
Yeah.
um
So okay.
inside the module itself. We have to write it inside the block, inside the procedure block. Okay. So I want to know that the always and if we use the forever inside the always block, then it will like neglect its functionality, because the always block is the infinite, can run the infinite times and forever also.
Yeah, ma'am. By in system Verilog, we can use the break statement, or we can
Yeah.
disable. If we are providing it was a like block like B1, we can go into disable this one.
But inside the initial, its functionality like increase the initial functionality. But the forever inside always will neglect the behavior of the always,
Yeah.
because it's itself is
Once it
the,
once it enters into the forever block, it's going to execute foreverly.
yes, yes, yes.
Infinite. Yeah.
Yeah, okay. Yeah, for we can like generate the clock for many ways, right? So
Yeah,
can
we can
we
generate.
generate it using the repeat statement, if you know?
Repeat. There is finite number we have to provide in the repeat loop, ma'am. So,
Yes.
uh, if we make that repeat is going to work like forever, we can generate the clock. Like
Okay.
we can generate by using the while as well.
Yes, you can generate.
While of constant one clock will be negation of clock. By using the repeat, uh, we need to provide the value here, ma'am. So 50. It is not an infinite one. We can provide for the 50 times. We can
50 is the transition or
uh,
the pulses. 50 will be the pulses or the
50 pulses.
transitions.
50 is a units, ma'am, like pulses.
So we will see the 50 pulses or the transitions.
50 transitions we will see, ma'am.
Yes, yes. Now correct. We will see the 50 transition or the
Yeah, ma'am,
pulses.
50
Okay.
times. Like the initial value of clock, if we are providing, like clock will be 1 tick be 0. Then 50 times it's going to toggle, like from 0 to 1, 1 to 0, 1 to 0, like 50 times.
Okay. What will be the output of this code? I've shared it.
Module test like x comma y initial begin x is equal to 0, y is equal to 0, fork join x is equal to 1, y equal to 1. So, x equal to 0, y is equal to 0. When after execution of y is equal to 0, our fork join will going to execute. Then x is equal to 1 and y is equal to x, the previous value of x uh, will be 0. That 0 value will be provided to y. So x value is 0 and y value is 0, ma'am. Ma'am?
You say you are saying the x value will be 0 and y value will be 0.
Yeah, ma'am.
I don't think it's correct. You can like rethink.
Let me check once again.
Okay, okay.
Okay. It's begin and inside the begin. Sorry, after execution of y is equal to 0, the value of fork. Inside these statements is blocking statements. Then x value is equal to 1. Then only after I is equal to x is going to execute. Now the x value is equal to 1, y value. X is equal to 1, y is equal to 1. Ma'am,
I don't think it's correct. You can like recheck it, or I will. You know ST?
Huh?
You know ST?
Yeah, I know about the definitions.
Okay.
Um, don't have any practical knowledge about.
Okay, fine. You can like continue telling the answer.
The values will be one only. No? Like I'm getting the one.
No, the value will be x is equal to 1 and y is equal to 0.
Okay, x equal to 1. Okay, then y value.
You can like recheck it after the interview.
Okay, no, sure.
So now you have to tell me the output. Tell me the output of this.
Module test hash parameter n is equal to 3. January I generate for is equal to 0 less
You
than.
know about the Genvar, right?
Yeah, ma'am, January. It's
Okay,
going
okay.
to be good in the elaboration phase. Um, for generate block, we can use for modules, function
What
definitions.
is the elaboration phase?
Like here, before the runtime, that our module elaboration is going to be happen. Like it's going to convert the primitives like AND gates and OR gates.
Can you repeat what were you saying?
Like in the elaboration phase, you are asking about now.
Yes, yes.
It's in between the compilation and runtime. It's in between the compilation and runtime, that elaboration. In the elaboration phase only, our whatever the design's hardware circuitry is going to be made by our compiler,
Okay.
like our RTL into the gate levels. Here we are using parameter like n value is equal to 3. So this generate block needs to execute for the 3 times, like 0, 1, and 2. In 0, if 0 percentile 2 equal to 0, it is an even number. So it's going to display the value uh, like block 0 even. Then after that, it iterates I is equal to I plus 1.
Can
Then
you like write the answer in the chat box? What will be the final output?
module table test hash 5. Okay. The module parameterizing is happening. No. Ma'am, here parameter overriding is happening, ma'am. While calling it, we are overriding the parameter n value with 5. So our iteration is going to be happen for 5 times. In the first time, value is 0, even. So this is going to execute, and after that our I will be I plus 1. So I value becomes 1. Then it will check the condition whether the I value is less than 5 or not. Yes, it is less than 5, and it will check if I value is 1 percentile to equal to 1, ma'am. So the condition is failing. So it will print the else statement. So
No,
if
I
I
want
value
the
is,
final output in the chat box, right? Okay.
yeah, ma'am, this is the.
Okay. Yes, correct, correct. It's correct. But you have iterated it till the 0, 1, 2, 3, 4, and 5. 5
No,
will, I
not
think.
5. Only 4 times. Since the condition fails here in the 4. Since I value 5 less than 5, no, the condition is failing. So it won't iterate it for only till 4.
Okay. What is the okay. Do you know about the supply 1 and supply 0?
Yeah, ma'am. Like we are providing the supply 1, the value will be a stable 1 value, the high value. And supply 0 means 0,
Okay, what will be the
like the
output of
logic
this?
0. Ma'am,
Yes. What will be the output of this question?
supply 1 VDD, supply 0 ground. Okay, ma'am. Wire not S and not equal to VDD, S and not equal to D0. Should begin at a time 0 that is that VDD makes 1. Unknown, ma'am. X. Since supply 1, we are providing with the continuous concurrent assignments. Along with the same, we are providing the supply 0, like 0 or the supply 0. Like we are providing the same 1 and 0, then it will be unknown.
Okay. Okay, fine. So this is the multi-driver, right?
Multi-driver issue. By using wired and wired R, we can override these issues more.
Can we like multi-drive the rig?
Uh, a trireg is there, Nama. By using that one, we can.
Do you know about the dollar URAN?
$U random, yeah, unsigned random values generation.
Okay. So why we need the randomization in system log?
Ma'am, here for the simple circuits, we can generate the numbers like if it is 2-bit. So the combinations will be 2 to the power of 2, 4. We can generate the 4 combination of values in the test bench. But if the value is like 100, so 2 to the power of 100 combination we need to generate. We can generate the 100 combination by writing the linear test bench, but uh, the debugging is highly impossible for that one, ma'am. So it is time consuming, so it will take a lot of time in order to find a bug. Through randomization we can randomize the values and we can generate and easily we can catch the bugs.
Okay. So what's the difference between the RAND and RANC?
Yeah, in RAND, a RAND is going to select the values from the variable. The same values will be going to be generated consequently. It's going to randomly pick one number from that sequence, ma'am. Like if you are using the RAND C, the RAND C is going cyclically it's going to generate the values. Like we are having 1, 2, 3 values for that variable. It's going to generate at first time 2, then it's going to generate 1 again, and after that 4, and after that 3. Then again it cyclically generate the same values. But in the case of RAND, it will generate 2, 3 times or 4 times. That is the difference between the RAND and RAND-C. We are mostly prefer the RAND one in the randomization.
Um, you have to write the Verilog code for this Moore FSM state to detect the sequence detector.
Draw the Moore FSM state diagram to detect the sequence 101101 or living around. Direct Verilog code, ma'am.
Yes.
Okay.
Can you draw the FSM diagram also, the state diagram?
Yeah, ma'am. I will write it on the copy. Is it fine, ma'am?
Yes, yes, fine. So you have made the n+1 states, right?
Yeah, ma'am.
For the
You are
Moore.
asking me to
Yes.
like Moore.
Yes, yes. Yeah, I have seen. You can continue with the Verilog code.
Okay.
One doubt is there for me. In your state diagram, you have moved the S6 state to the S2.
S6 state to S2, ma'am. Yeah, ma'am. Whenever the input is 0,
Why? We are
like,
not starting with the 0, right? We are starting with the 1.
ma'am, it's a overlapped sequence, ma'am.
Yes, it's overlapping. So how we can?
So here our sequence is 101101, ma'am. Like double the next value will be 110. If you are having 10 here, 10, we are taking out the 1, and after that 01. There is no state with 01, so we are taking out the values. In
Why we have not gone to the S3 or S1?
here we are having a match now, ma'am. The next sequence match is there here. That's why. Now the sequence is 0111010. So here,
The
there is,
sequence was 101101.
yeah, ma'am. After detecting the sequence, if the value from the input is 0, then our sequence is going to be 011011. So I'm taking out the 0 now, since the sequence will be started with 10. So I'm checking for where there is the combination of 10. So I found here 1010. There is no sequence with 1010. So I am neglecting this one. So I am considering only 10. If we are considering 10, then it will be a state 2. That's fine. No?
Okay, fine.
Yeah. Can I do the coding part?
Yes, yes. You have missed one state, I think.
6. 101.
You can use the ternary operator. It will be easy, I think, right?
Yeah, but I am in the middle of the.
But I missed what you have said.
I'm middle of this case, ma'am. So
Yeah, okay, okay,
I will
fine.
come.
I was just suggesting you that you
Yeah.
can.
Okay.
Okay. Yeah, I understood the framework. And after this, what we write, like we write the output logic, right? How we write it.
Sn out equal to output equal to 7. Then um,
I think it should be like six. Is six. Okay, you are writing the next date. Okay, okay.
the next state equal to S7. So
Okay, okay, fine. Yeah, it's correct.
Can I need to write the test bench as well?
No, 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 no.
Okay.
Okay. So I think that's all for today. Okay.
Okay.
Do you have any doubts or any question for me?
No, ma'am. Like I wanted to know how well I am saying the answers, or is there anything I need to improve? What was the
Yeah,
feedback?
I think you were confident and your introduction was good. Because many students give like one, two, three, two or three line introduction, but your introduction was in brief and well maintained and managed. So I think that was good. But um, you can like revise more concepts, and we will take the next mock interview with with more system Verilog and UM and project questions. Okay,
Okay, ma'am. That will be on, that mock interview will be on.
that will be can be in next week. You
Oh,
can like
like
schedule a day and a message
actually
to
I
them.
prepared the system Verilog and UVM also, ma'am. So that
Okay,
projects only I left. Like once if I revise them, that will be good enough.
okay, okay. I will in the next interview we will focus mainly on the system Verilog UM.
Okay, ma'am.
Okay,
Thank you,
okay.
ma'am.
You can like share the date and time with Rajat sir for the next week in which you have to give you want to give the interview,
Okay, ma'am.
Monday to Friday.
Okay, ma'am. Let me take the next week, Monday itself.
Okay, okay. You can like message to Rajat sir.
Okay, ma'am.
Okay, thank you.
Thank you, ma'am. Have a good day, ma'am.
Thank you, you too.